So in this video, we are going to learn how to graph non-transformation. So this is where we'll analyze asymptotes, wholes, look for domain restrictions, zeros. So we start by factoring our polynomial. Numerator, t-chart, what multiplies to 2 adds to -3. And in the denominator, we have a GCF of x. Alright, so starting with our domain restriction, looking at the denominator, x cannot equal 0 or 1, setting each piece equal to 0. Vertical asymptote occurs where the factor does not cancel. So x does not cancel with anything in the numerator, so that's our vertical asymptote. And then we have a whole at x equals 1, because that is a common factor with the numerator, it would cancel out. Horizontal asymptote, that's where we identify the degree of the numerator, which is 2, the degree of the denominator, which is 2. When they are equal, you do lead coefficient divided by lead coefficient. So in this case, 1 divided by 1, we have a horizontal asymptote at 1. And our 0 will occur where the numerator equals 0. Now the x minus 1 would cancel, so the only piece left is x equals 2. And we sketch everything. Alright, so we start with our asymptotes. X equals 0 is the y-axis. And our horizontal asymptote at y equals 1. We sketch our 0, our graph crosses the x-axis at 2. So on this side, we can see where our curve would be. It'll curve closer to our asymptote. And as we're curving back towards the y-axis, be careful that you don't forget about this whole. So here's how we graph the whole. When we get to x equals 1, we just make a little circle and keep going. Now we have nothing for the negative values. It doesn't cross the x-axis, so we know that our curve is entirely above our asymptote, our horizontal one. So I'm going to substitute a few numbers in. First of all, I'm going to simplify my function. I'm just going to make a quick little t-chart. If I substitute -1 for x, what do I get for y? I get -3 over -1, or 3. If I substitute -2 in for x, I'm getting -4 over -2, which is 2. So it'll give me a couple of points to give me an idea of where my graph will curve off to this side. And I can see it kind of between the asymptotes curving a little bit. Last example. Again, we start by factoring everything. Numerator is factored. Our denominator is the difference of squares, x minus 2x plus 2. Identify a domain where the denominator equals 0, so x cannot equal -2 or +2. Since neither one of those cancels with the numerator, we have 2 vertical asymptotes. So we'll see what a graph looks like with more than one vertical asymptote. It's a little bit different than the hyperbola. Because nothing canceled, we have no wholes. Horizontal asymptote, let's look at the degree of the numerator, which is 1. Degree of the denominator is 2. When the degree of the numerator is less than the degree of the denominator, horizontal asymptote is y equals 0, or the x-axis. And the zeros, where the numerator equals 0 at x equals 3. So we sketch everything all together, starting with my vertical asymptotes at -2 and +2. And I've got a horizontal asymptote at y equals 0. And it tells me I have a 0 at x equals 3, which is on my horizontal asymptote. Now let me give you an updated definition of what an asymptote is. It's a graph that a line approaches as x gets very big or very small. It actually can cross the asymptote, and in this case, it does. And we'll see what that asymptote does when we cross the graph. But again, this gives me very little information about my graph. I've got 1 point, and I've got some asymptotes, but I have no idea what's going on for the most part. So we're just going to substitute a few points in and see if we can't figure it out. So I'm going to start to the left of -2, and I'm just going to pick a couple of points right around just to the left of -2, because I've got those asymptotes to help give me direction as well. So I'm going to substitute in -3 and see what happens. So in the numerator, I would add -6, in the denominator, I would have negative 5 times 1. So it's a little bit bigger than 1, 6/5. If I substituted negative 4, I would have negative 7 over negative 6 times 2. So it's a little bit smaller than 1, 7/12. So that gives me an idea of where my graph is headed and how the asymptotes can help me get the rest of the curve. So I'm going to go negative 3, a little bit bigger than 1, and then negative 4, a little bit bigger than 1/2. And then using the asymptotes, I can get the rest of my curve. Sorry, that got a little too close to the asymptote there. All right, now I need to figure out what's going on between negative 2 and 2. So I'm going to substitute negative 1, 0, and 1 and see if I can't figure out what's happening. We have negative 4 over negative 3 times 1, so a little bit bigger than 1. If I substitute 0, I get negative 3 over negative 4, so a little bit smaller than 1. And if I substitute 1, I get negative 2 over negative 1 times 3, 2/3. Did I do that right? Because I'm thinking it should have looked a little bit different, so I'm just going to double check my math real quick. All right, so I'm going to plot these points. So we've got negative 1, a little bit bigger than 1. And 0, 3/4, and 1, 2/3. So using my asymptotes, it actually comes back up over on this side, which is what I was hoping my points would give me the information for. And finally, what's going on over here? So to save time, because this is already a really long video, instead of substituting values in, I'm just going to show you what happens. The graph comes up, goes through the 0, and it comes back down towards our asymptote. And the U-try problems. By the way, if you were worried about that last example that we just saw, you won't see anything quite that complicated on your test. They'll be the more basic ones, either the transformations or like the previous example where it was a little bit more straightforward, only one vertical asymptote.